Okay, now we are all set to write the program for double-ended queue. I have just updated the menu there. It's the same menu function that we used for FIFO queue, and I have just added two more options there. And also I have updated the switch case statement there and added two options. Since we have two more options here instead of NQ and DQ, we have four options actually: insertion at rear and insertion at front, along with deletion from rear and front, deletion from front. So I just have updated the switch case statement with those four options there. The actual algorithm will be implemented in these four functions. You can see that: insertion at rear, deletion from rear, insertion at front, and del from rear. So I'll be implementing these four functions exactly according to the algorithm that we did earlier. Okay, let's move ahead. You can see that I have completed this function init queue, and that is initializing the front at 0 and rear at -1. And we have the same structure for the queue implementation. Okay, so I can just increase the size of this. Let's make that 20. So let's now write the insert at rear function first in order to insert a new element at the rear end of the queue. So our queue pointer is qp, and the value that we receive here is v that we need to insert at the rear end. First of all, you need to check if the rear end is at size -1 or not. So qp arrow rear. If that is equals size -1, then you just need to print a message there that unable to insert at the rear end, and we need to exit just by using the return statement that will terminate this function. Otherwise, we need to increase the rear by 1. So qp arrow rear equals qp arrow rear plus 1. You can use qp arrow rear plus plus instead. That also works. Okay, now we need to place the new value v at the rear end of the item array. So qp arrow item qp arrow rear equals v, and we are done. Now let's do the insertion at front first. In that case, let me just copy this. Okay, now insertion at front requires the front to be at least greater than 0. So if the front is at 0, then you cannot just move the front downwards. That means you cannot decrement the front anymore there. So unable to insert at the front end, that's going to be the message. And then we need to return from this function if that overflow happens. That means if we are unable to insert at the front. Otherwise, we need to decrease the front by 1. So qp arrow front minus minus, that will decrement the front by 1, and then we need to place the new value v at the front of the array. So qp arrow item and qp arrow front, and that's going to be v equals v. Let me update the parameter there. Okay, it's going to be pointer qp, oops, and the value is v. Okay, and now let me just write the delete from rear there. If qp arrow front is greater than qp arrow rear, then we need to just print a message there that queue is underflow, and we need to terminate from this. We need to come out from this deletion operation. However, we would require to return an absurd value from there because we have promised so here in the return statement of the function. Whatever the way that the function gets terminated, we must always return a value to the caller. So we are returning absurd value -9999 to the caller. So if the caller gets -9999 there, it will understand that the queue is underflow. You can see that we have managed that thing here while we call that function. You see that we are calling this and we are getting the deleted value at value, and then we are checking whether it is -9999 or not. If that happens, then what we are doing, we are just printing queue underflow. Since we are printing the message here, we can just delete that from there in the function. Okay, let it be the task of the caller. Now if the queue is not underflow, then we can just pick the value from the rear and can decrement the rear by 1. So int v equals qp arrow item and qp arrow rear, And then we need to decrement the rear by 1, so qpr rear minus minus. And finally we need to return the value p to the caller. So that's the deletion from rear operation, and now we can move ahead and can write the deletion from front. Let me just change this. It should be deletion from front. Okay, now let it be a task for you. I'm not going to complete this function del underscore from underscore front. Okay, I'm just writing this. I hope if you have understood the algorithm, then you can just implement this deletion from front easily. So if not, then should you face any kind of issues they are implementing this function, just message me in the forum. I'll be replying you with the solution. Okay, no worries, just keep going, just try hard, you can do that. Just I'm printing a message, you need to implement this by yourself. Okay, and I'm returning an absurd value minus 9999 from here, as I need to do so because as the function is expected to return an integer when it terminates. Okay, so we are done with this. I have only left this implementation for you as a task, and rest of the functions are done. Now let us go ahead and check if these are okay or not, as far as the functions that I have implemented, the first 3 functions, whether they are working correctly or not. I'll just go ahead and run this. The name of the file is deq.c. So let me compile that. Hold on, I need a quick correction. I need to mention the parameters name there. Okay, since I did the copy paste job, that's why I missed them. The side effect of copy paste. Anyway, we are done now. Okay, let's go ahead and try to compile that once more. deq.c. Okay, it's done. Now I'm running this. Now option 4 is not going to work. If we just give option 4, it will say that, okay, hold on, we need to update this as well. Okay, let's try to compile once more. I think it's going to go through this time. gcc deq.c. So it's done. Now try to execute that. /a.out. Yeah, here it is. Now if you choose menu option 4, it's not going to work. It will say that you need to implement by yourself. Okay, there it is. It's your task. Now I'm choosing option 1. Okay, giving there 100 to insert at the rear. It has been inserted successfully. Then I'm giving 200 again to insert at rear. It's done. Now I'll do that once more. 300. Okay, now if I want to delete from rear, I'll just choose 3 and it will delete from rear again. Okay, I cannot insert at front because the front is at index 1. I'm sorry, at index 0, and unless and until you delete from front, you cannot just test whether the insert at front works right now correctly or not. It will work perfectly. So I will just want you to, I definitely want you to implement that option 4, delete from front, and then you can check the insertion at front. So let's go ahead and try that and complete the rest of the program. That means you need to complete only one function there. With this, we come to the end of this section. Let us wrap up understanding the queue data structure. Now in the next section, I'm going to introduce linked list to you. That's going to be a whole new data structure, and we'll be implementing both this stack and queues using linked list as well. That's going to be interesting. Thank you very much for watching.